All right, welcome everyone. Today's session is managing metadata in the browser with the tooling API, WebWorkers, and JSZip. It should be fun. I hope you guys can get something out of it and enjoy it. So I'm Zach McElrath. I'm a lead software engineer at Squidify. We're over in the dev zone. Come join us. I'm going to be using Squid to do the user interface for part of what I'm showing today. So if you like what you see, you can come by our booth. We'll show you some other cool stuff. Okay, so background of this session is metadata management on Salesforce. What the current state is, people typically have all kinds of different files that they store in Salesforce for development. You have everything, Apex classes, triggers, Visualforce pages, and one that people often use for storing more static content is static resources. Static resources is a little bit of a misnomer because you can use it to store JavaScript and CoffeeScript, CSS, images, icons, PDFs, all kinds of stuff, zip files. People store tons of stuff. It's kind of like the catch-all placeholder for metadata. And there are a lot of benefits to using static resources. Salesforce doesn't treat them quite the same, but that's where a lot of web development kind of resources end up living because they're the easiest place to put things. You typically edit metadata in Salesforce with the Eclipse IDE. The Sublime plus Maven's Mate is a great tool that's come out in the past few years. Maven's has a great plugin that makes it really easy to use Sublime text. We highly recommend that. And even in the past few years, the developer console has really matured a lot, especially in the fact that with a couple releases ago, they let you start editing static resources in the developer console. So you can create a new text/JavaScript static resource, a new CSS file, and it sets the MIME type correctly, and you're able to just start adding those in really easily. So that's been a big improvement because so many people actually use static resources for exactly that. I think Salesforce kind of picked up on that. So what today's session is about, though, is build processes for metadata on Salesforce. Typically, build processes in Salesforce are done with a combination of a really great tool, which I'll talk about, called Grunt, using some open source plugins called Enforce, brought to you by Kevin O'Hara. He did a great session on that last year. And another tool he wrote, again, Grunt Ant SFDC. It's a Grunt plugin that lets you deploy metadata to and retrieve metadata from Salesforce. Then Salesforce also has this tool called the Ant Migration Toolkit, which lets you run XML-based Ant jobs that will move data to and from orgs. And then there's a lot of manual uploads. People often do a lot of, let's just grab this zip file, grab this JS, and let's put it in a static resource. There we go. All right. So that's kind of the current state. Honestly, that's a lot of it. There are some people will do some scripted deployments with other things, but for a lot of things, these are the main tools people use. Now, if you're a web developer coming to the Salesforce platform, some of the common tasks, some of the common build tasks that you might have to do and that you're used to are things like the following. Compilation of CoffeeScript into JavaScript. CoffeeScript's a great new way to get rid of the semicolons in JavaScript, among other things. No, but it's a lot of people are trying to use different preprocessor technologies to help make their writing of JavaScript and CSS better. So in the CSS world, there's technologies such as less and SASS. The aptly named less aims to make you write less CSS by having variables and mix-ins and some functions that can let you dump a bunch of variables into a whole bunch of different places, so you don't have to write the same thing over and over and over again. And then, especially for JavaScript development, concatenation of files is a big thing. So you might want to have a whole bunch of JavaScript source code files, and then you might want to build them all into one big file. Then you might want to get rid of the console logs and debug statements. That's a common thing. You might want to then minify or uglify your code so that people can't steal it on the web. That's basically source code protection on the web, is minifying it and turning the variable names into A, B, C, D, E, and F so no one knows what it looks like and what it does. Another big thing is creation and modification of zip files. So you will often build a lot of, especially in Salesforce, this is big because zip files have a lot of special features when you upload a zip file to a static resource. But you might want to take a whole bunch of images and CSS and put them all into a zip file so that the relative URLs in your CSS all point to the right images folder and the image icons and stuff like that. So building zip files is a big deal. And then unit testing. I love unit testing. It's saved my butt so many times. So if you're not writing unit tests, you should. And some big JavaScript frameworks out there for unit testing. QUnit, Jasmine. There's some others that are really good too. But just pick one and write some tests. But that's a big part of build process is doing unit test running. And then pushing and pulling to GitHub. So you may change it or other source code repos. Take your code and put it somewhere. So those are some common web developer build tasks. Now you take all of those, moving to Salesforce, and you have some additional Salesforce build tasks. One of the things you want to do is you want to take all these web things you're building and put them into static resources. So either do an insert if it doesn't exist yet, or do an update. Then you might want to add some Visualforce pages, components, classes, triggers, all the typical Salesforce metadata. Put those up to your Salesforce org, and then retrieve and deploy, basically, is what we're talking about. Getting stuff into Salesforce and out of Salesforce. OK, so for Salesforce right now, I'm going to talk about what I think the current best option is. And that is Grunt. So Grunt.js is an awesome tool that has just blown up over the past few years in the web and took since Node.js came out, it was like one of the #1 JavaScript open source app the last 2 years, or 2 years ago. There are so many people that have added modules to this. It's phenomenal. So Grunt it lets you basically write a configuration file that defines all the tasks you want to do. So things from like concatenating files, minifying, compilation of less and SASS into CSS, removal of console logs, get, push, pull, all that kind of stuff. So the pros of Grunt, there's a built-in module for just about anything you can imagine. There really is. If there's not a Grunt task yet, you should feel privileged that you're charting new territory. And one of the nice things about it is that it's configured using JavaScript. So if you're familiar with JavaScript, that's nice. That's also a con, depending on how you look at it. Because it's not declarative, it is JavaScript, and that doesn't float everybody's boat. As I said, it's extensible and open source, so that is great. There are lots of changes being made on a regular basis to modules, that's what you want if you're stuck and it's not working. They have a good sense of dependency management. There's a good build system built in for that, and upgrades. Basically, it's all done using Node's package manager. So it's all built on Node.js. And that is one of the things I think is one of the big cons, is that it runs on your computer. So all of your build processes have to be run from a local machine. There's no button you can push in the cloud that just runs a whole sequence of Grunt, unless you have a whole server set up that is basically got all your stuff running. So you have to have another server that's doing your build tasks, connecting to Salesforce, so you have to handle authentication. That's one of the big things is in order to do this and connect with Salesforce, it requires creating a connected app and establishing like an OAuth connection for authentication. Fortunately, there are some helpful modules for that. There's Enforce, as I mentioned before, which takes care of authentication and has a lot of built-in methods for REST API connections. So doing inserts, updates, deletes, all that stuff, and running. Enforce is a great library. If you're trying to do Salesforce stuff on Node, highly recommend it. But the one other big thing that I think is really difficult about Grunt is trying to run asynchronous operations in series, and especially ones that involve connecting to Salesforce data. It is not trivial. Even if you can follow other people's examples, follow their thread where people have gone before and try to build on that, but everybody's process is slightly different. You may have to create these files, then create this file, then create this file, and you have to manage that whole asynchronous process, make sure all your ducks are in a row. And in JavaScript, that's not easy. Especially, you really have to know what you're doing when you're putting all these different people's modules together. So if you were into writing JavaScript code, have fun with that. But I'm going to present today a different alternative, another way to do it. We call introducing compile. So compile is a way to define build processes in Salesforce with clicks, not code. You can store your processes as Salesforce data rather than in a local Grunt file on your machine. That other people don't know about it when you make changes unless you're really rigorous about making your changes known to other people. You can run your process, and you can run your processes natively and securely in your Salesforce org. So basically the idea is build processes on Salesforce in Salesforce. How does it work? You define a build process. You can have a bunch of them. Each process has a bunch of steps. So one step could be grab files from a static resource, get them into local memory. The next step would be concatenate those files into one big file. And a final step could be save that back to Salesforce. So each step runs one of a set of actions that are defined, or it could run another process. There's lots of different action types that are in there that I've added right now. So some of the ones I was saying, load static resources, concatenate. Also, there's ones for compiling less to CSS, ones for creating zip files, minifying JavaScript, and updating static resources. But there's a lot more that I'd like to do. We'll talk more about that later. So here's a screenshot of it. We're going to show a bunch of demos. But on the left, you have your list of processes. So you might have one process called build all JavaScript for production. One would be build CSS, construct your themes out of your less files. And then on the right is the process editor. So you can organize the steps in your process and pick which actions to run. Then you hit the run button, and that actually runs your process in Salesforce. So to build this, I used a couple technologies. One was the Salesforce REST and tooling API. Use that to get metadata files out of Salesforce and to create and update metadata files. For the user interface that we just showed, I used Squid. That helped me create a kind of a complex UI with children and grandchildren records related to each other, and that is really quick updating. Nested drawers for showing and hiding data, keeping it organized. That was just very, very helpful to get that done really fast. And then doing some of the queries for metadata files and updates, use Squid as well for that. And then finally, lots of JavaScript open source libraries, especially Grunt was the inspiration, and borrowed using a bunch of different modules to help kind of get this initial prototype done. All right, let's jump into a demo. For our first demo, we're going to use compile to do a JavaScript build process. So the first thing we're going to do is we're going to retrieve static resource files. Just like I said, we're going to concatenate them together, and then we're going to minify the source code, and then we're going to go update or create a static resource in Salesforce. OK, so let's get out of here. Let's go to org. OK, so here we are in an org with compile in it. Right now, I don't have deleted all my processes. I'm going to click create and click new. Say df14 JavaScript build. So I'll create the process, and that'll load up the process over here in the right side. The first thing I'm going to do is add a new step. So if I click the little wrench icon here, this will let me pop open my editor. So the first thing I want to do is I want to get static resource files out of Salesforce and into my memory so that I can manipulate them. So compile has a file system that is basically in memory. It's not local on your computer. It's in your browser's memory. So that's one of the goals. The goal of this was to never touch the local machine. Basically do it all in your browser in the cloud. So here what I do is I'm going to load static resources. So let's pick the resources I want. So I have, over my static resources, I have 3 JavaScript source files. One is a Fibonacci function. One is a string distance calculation. The other one is hello world. So really revolutionary stuff. But I'm going to take those 3 files, and I want to kind of put them all together into one big file. So I'll search for my static resource files here, JS file A, JS file C, so it's an autocomplete. And I'll say I'm going to give this one a local name in my in compile's file system. So I'll say filec.js. So there we go. That should load my files in. Next thing I'm going to do is I'm going to concatenate them all together in one big file. So I'll pick concatenate files. Say first I'll do file A, then file B, then file C. I'm going to move them all into one other file memory called combined.js. In my third step, I'm going to I'm going to minify the source code for those files. So I'll pick one of my source file there. Destination file, I'll call this combined min.js. My final step, I want to save these back up to Salesforce. So we'll say create update static resources. We'll do two here. We'll save both the min version and the max version. So we'll say combined.js. This will go to a resource called combined.js. This one we'll call combined.js min. We'll grab our combined min there. So this should create two static resources containing the contents of those files. So let's save this. There we go. And now we'll hit run process. So this is going to give me a live update as it's running. So in the blue, it's basically the title of the steps. Shows me how it's going. Click close. Now let's go back over to my resources and check this out. Okay, so there we go. We have two new resources. We have combined.js and JS min. Let's just pop these open to see show what's going on. First, I just want to show one of these original files, just so we see them, not just creating random stuff. So I have this little function that says say hello. That's the boring one. The Fibonacci one's more exciting. But now the next thing we'll do is we'll check out our large file just to see them all put together. So we have the hello function, then we have our distance function, and then we have the Fibonacci number. So they're all kind of run together in one file. And then finally, we're going to put here's our minified version of that file. So got those together, did a little build process in like 30 seconds. Hopefully that's exciting. If it's not, maybe something else will be. Okay, so all right, so now for the next thing I want to show is let's just kind of talk about how we did that. First code, we're going to do a couple code samples here, just kind of summarize how we're actually making this so that you guys get a sense of how you can like this. The first thing we're doing is we're going to retrieve metadata files from Salesforce using the tooling API. So for those of you guys not familiar with it, the tooling API gives you ways to build things like the developer console, but it also can just be used to grab certain object types that are not exposed through the regular REST API. You can make queries that have access to different objects, additional metadata objects. That's a benefit. But at basic level, we're just going to do a query. You can go to, so we're going to use jQuery to do an AJAX call to the Salesforce REST API. We're passing in our session ID that we have in our browser. So like Squid gives us a session ID, then I just use that. Now here's my query up here. I can code the query. I say I just want to go get static resource files where the name is in a list of static resource names. So JS file A and B. And then when I'm done, I want to get out the records in my success function. Now the next trick that when you're trying to work with metadata bodies is that the body field that you get from a query, like on static resource or Apex class, it's markup on some of the other ones. The body that you get back is not the actual body. It's a URL. So what you need to go do is get that URL and then go get it. You have to take that URL and go to another AJAX call. This is where the asynchronous stuff starts getting really crazy, because you have to do these in a sequence. You have to wait for them to be done and keep that going, keep that process going. So we just go to that URL and we return it. We request it as text. And that's really important, the data type text there, because it could come back as if it's a script file. It's sometimes jQuery AJAX will try to run the script. That's not what you want. You're trying to manipulate the text body, not run the script. So make sure you have data type text on there. So that's how easy it is to actually just get metadata file bodies using the tooling API. Now the next thing I'm going to show is how do we modify the bodies. So I'm going to go through insert, update, and delete really quick. Insert is the most complicated, and it's not too bad. But first here, for this simple example, we're just going to have a silly little body of function AB return A plus B. And then, so file name, body, the content type, and cache control, those fields you should set you need to set at least name and body when creating a new resource. And that's true for, I think, the other metadata types as well. But basically all you're doing is a post. You're doing a post request to the services data, S-objects. And then if you're doing it's a regular REST API post, except when you're going to the trying to do a save an Apex class, then you have to use the tooling prefix. Random, kind of strange, but good to know. Otherwise, you'll just be like, this isn't working. Now, in order to set the body of your new resource, you need to pass that along as a data in your AJAX request as JSON. So you build your record. I built my record up in lines 12 through 17, just an object, and then I stringify it before sending. The one other trick, the one other most confusing thing of the whole metadata thing for me was, how do you encode the file? Well, it has to end up in base 64. That's annoying. But it's more annoying than that because you don't just use window.b2a, if you've ever used that. That's basically take ASCII and convert to binary. Or I always forget which order. I always forget the order. But it's not just that. What you actually have to do, because the string could contain invalid UTF-8 characters. Imagine that. And that's bad. It doesn't work. So what you have to do is you have to encode the string, unescape it, then base 64 encode it. So as if that wasn't obvious enough, that's all there is to it. So if you use this little function up here, you'll avoid that. So that's why I wrote it in here. But that'll help you get your body into Salesforce. Updates, fortunately, are very similar. You do a patch request down line 17. That's how you actually tell it to do an update. Plus, the URL is just slash and then row ID at the end. So you're saying, I'm updating this record. And then all you have to pass along as the body is your new metadata body. So you change your function. Now you change your JavaScript file, put the new body in there. Don't forget to UTF-8 to base 64 it, and then put it in there. So same as before. Delete is super easy. Just do a delete request to the URL with the row.id on the end. So that's basically a summary of querying for and updating metadata bodies. Let's do another demo. So here for compile, we're gonna retrieve static resources again. For this one, we're going to compile less files into CSS, and then we're going to build a zip file that contains some folders. It contains a source less file and the output CSS files, and we're going to show how to use the zip tool for this. Okay, so let's back out again. All right, so let's create a new process. df14 less CSS build. Save and create. All right, first step, let's get some files out of Salesforce. Say load static resources into memory again. Here we only have one file we're gonna use, just for example, and it's a less file. So I'll call this test.less. Now, just so if you guys aren't familiar with less, I just want to show you kind of an example of what this looks like. Here's the file. It's got some weird things. You're like, that's not CSS. That's got bogus stuff in it. Well, that's cool. That's true. But there's things like variables, which are really great because you can spit them out into all different places, and that way you don't have to write the same font color 100 times in your file. Very nice. So we're going to take this file and compile it into a CSS file, which it'll be a lot longer, but it'll have the inputs spat out in a bunch of different places. So that's what we're working with. The next thing we're going to do is we're going to compile this file. So we're going to take the first option, say, grab our less file, we're going to output it to test.css. So the output will be a CSS file. Now we get to the fun one. We're going to build a zip file. So the first thing we're going to do is we're going to say which files do we want to include in our zip. And we're going to get both the CSS and the less file. What we can do with this zip tool is we can actually create folder structures and put files into them just in one line. So if I want to put for my I want to have a file folder called output. I'll say output main CSS. So I'm going to change the name, put it in a folder, and then I have another one called source. We'll call this one main.less. Now, just to show we can do this as well, we're going to put our test file also into a local one, just in the low-level folder. So Zip's going to have a main folder, have some files in it, then it's going to have some nested folders in it with files in them. So we'll put main.less. Okay. Now we're going to give this a name of a local file here. We'll call this test zip. Let's do a test zip, and then final step. We're going to save the zip up to Salesforce. So create update static resources. Source file name is testzip, and we'll call this one testzip. All right, let's run this thing. All right, sweet. Looks good. Let's go see our zip. All right, so there's our zip file. So it's I'm typed application zip. Let's go look and see what's actually inside of it. So we're going to download this thing, load it up. OK, so you notice in the main directory we have the main CSS, main.less, and then we have two folders created. One output has the CSS file, and then one source that has the less file. So that was done using the awesome library called JSZip. And I'm going to talk a little bit about that because it's very cool. And very useful for a lot of development projects on Salesforce because with zips, there are some benefits in Salesforce is that you can, if you upload a zip file, all the files in nested directories can be accessed using the URL /resource name, and then the folder structure just starts from there. So if it's in a file, what I just did, like output /main.css is accessible through /resource, so testzip /output /main.css. That Salesforce kind of hosts your whole zip file structure for you. So that's a really nice benefit of you working with zip files. So here's how you use the library JSZip. Say var zip, new zip, and then if I want to put a file in the root directory, it's just that zip.file, file name, and then put in the body. So that creates it in the local directory. I can also create folders with a zip.folder commands. That would create a folder called JS. And then if I want to put files in them, I just say folder.file. Now it's actually even easier than that though. Like on line 15 and 16, you can just write the whole file's folder structure name right into the file name, and it'll create those folders for you if you say create folders true. So it doesn't really they make it really, really easy to build zip files. And then the important thing for getting this into Salesforce is you do zip.generate. That generates the content that you want to actually put. So use type base64 and compression deflate. And then that's the body you put into your static resource. Don't UTF-8 to base64 it again. That'll screw you up. So just take this raw thing. That's what goes into the static resource. All right, for a final code sample, we're going to talk about web workers. So how do you do high-performance asynchronous JavaScript? And before I go, you're probably like, OK, why is this relevant? Why should I care? Well, if you've ever seen this, terrible, terrible. The following pages have become unresponsive. You can wait for them to become responsive, or you can kill them. That actually is kind of a funny joke on mobile. You can wait for them to become responsive. Somehow they're magically going to become responsive. No. But the browser is choking. Your users you can't use your page. Your whole browser is crashing. Why? Because you have some really complicated JavaScript. You terrible developer. How dare you write that? And your pages are dying. If you've seen this, you need web workers. Web workers are your new best friend. Let me explain. What are web workers? Web workers allow you to run complex JavaScript in separate worker threads in the browser. That frees up your main thread so that your workers can your users can keep working. So they don't get those running. You've got asynchronous code going on in the background. Your users are still doing stuff. They don't even know that your browser is churning like a madman, running some complex image processing algorithm. All they know is they can still work. That's the goal. That's what WebWorkers lets you do. Now, the other thing is they let you can do message passing to and from your separate threads so that your users know what's going on and that you can use that. Use the result of that back in your main app. So why would I care? What's a use case for this? Well, big one that was actually my impetus was parsing very large JSON strings. I was working on a project for a customer, and they had the amount of metadata they had in their case object was like 6 megs. So they had about 1.5 million pickless values. It was insane. And the browser was hanging when I tried to parse that string out of the API. It was terrible. So it's like there's got to be a better way to parse this somewhere and not kill the browser. That's what WebWorkers does. Other ones I've seen are image and video manipulation. I've seen someone do live motion detection in a live video stream using JavaScript, not Flash. All JavaScript, HTML5, Canvas. This is possible, but do it in a web worker, not your browser thread, or your user will immediately get the infamous unresponsive page error. Now, it's also good for really complex algorithms in JavaScript that, such as zip file compression. If you have a massive amount of stuff you're trying to zip, that can be some taxing stuff on the browser as well. So that might get you thinking about some things you can use it for. And browsers are becoming so powerful that they can handle this stuff. You can do stuff in the browser you never thought you could, even on your phone. I mean, it's getting to that point. So how does these work? I'll give you a few samples of this. This is what using a worker in the browser looks like. You say var worker equals new worker, and then you pass it a link to, or you pass it a URL. So you have in Salesforce, what that looks like is you probably want to store your worker code in a static resource file. Now I'll explain that date, get, time in a minute, but you want to store the content of what your worker is going to do in a static resource file. Now again, it could be inside a zip with the whole zip file structure thing, but separate file. And then what you do in the browser is you say, I want to listen for messages from my worker, and I want to post messages to my worker. That's basically all there is to it. That's the only communication between workers is listen for messages and post messages. So you say, let's listen for a message. And what I'm expecting in this sample, I'm expecting to get back an uglified JavaScript file. So I'm going to say that in line 11, I'm going to post a message, say, worker, here's your task. Uglify this code. Here's my source contents. I'm using compile's file system here. So get my contents. Worker, go uglify this stuff. Now I'll explain the base URL in a second, too. That's important. But in your worker file, this is all it is. It says, all right, let's listen for a message. Now if I get a task that says uglify from what I'm going to do is I'm going to uglify it. And when I'm done, so in line 26 or 28, I'm going to post a message, and that's going to go back to the browser. So whoever spun me up, it's going to go there. And what I'm posting is I'm posting my contents. Now I'm using the uglify command there on the data file contents. But your question probably is, what does that do? Uglify, where's that defined? Well, it's not defined until you load an external library. So a benefit of WebWorkers is you can actually you don't have to have all your code in this separate worker file. You can load in other script libraries, which is great. And again, you can load them from Salesforce. The problem is you have to when you're inside a worker, workers hate being relative URLs. They're like, no relative URLs. I don't like that. You give me an absolute URL or I'm mad at you. So to get an absolute URL, what we're doing is we're passing in the base URL from Salesforce. So example there, just go back to the previous one. On line 14, example would be like na17 visual.force.com. That's my base URL. So that way I can have an absolute URL in my worker. So that's important. That's a little important thing that'll trip you up. So altogether, what this looks like is this is basically just the two things. But the third point I was going to say is you pass in the base URL, and you have to use the absolute URLs. The one other thing is on line 3, when I'm requesting my resource location and on line 22, I'm sticking in newDate.getTime in between my resource and my resource name. The reason I'm doing that is that forces Salesforce to not return a cached result. So that's not necessary when you have a final version and it's all set, but when you're developing, this will drive you nuts unless you do this. You want to put in this random time or something so that Salesforce will always spit you back whatever's your most recent copy. So if you're just making some changes to your file and you're like, it's not showing up. What? I know that's a console log in there. I know this is supposed to be running. It's because your browser's serving you a cached version. And this is a really good way to stop that from happening. That's a good trick with any time you're using Salesforce static resources. That's basically that's how easy it is to use workers. They're supported from IE8 on up. So don't be afraid to use them, because Salesforce is going to de-support IE8, even IE8 in 2015. So have fun. We're all excited about that. And yeah, lots of good stuff. So in conclusion, what is, just want to summarize what compile lets you do. It lets you build processes with clicks, not code, and store processes as Salesforce data. So you log back into Salesforce, your whole build process is there. If anybody, multiple people can make changes to it, add stuff to it. You can control access to it just with Salesforce data. And you can run the processes in the cloud, in your org, natively and securely. No file passing. You don't have to have OAuth credentials or anything like that. You don't have to worry about secrets and all that stuff. It's just native in Salesforce. And compile is going to be open source. So what does that mean? So it's built, for the UI for compile, it's built on top of Squid. So the first thing you need to do is to install Squid in your org. In a DE org, or developer edition, you can have Squid for free forever, which is great. And in production, it's a 30-day free trial. And then after that, it's $10 per user per month for a full user. But it's really helpful for doing this UI. And the next thing is I'll be trying to release a link for compile soon, and a GitHub repo for the code. It's not up yet, but I'll try to post it to the session chatter feed. And then once that's up there, I'll try to have a good README file helping you say, how do you contribute? How do you change things? Because it was made to be extended. Obviously, there are lots of areas for improvement. You think about how much other build processes there are. There's lots more action types that should be written. I want to be able to run Apex tests using the tooling API. That should be pretty quick to build. Running JavaScript tests, doing code linting and validation, doing GitHub push-pull. There's so many things we could add to it. And then just making every option type have more configuration options. All right, so that's it. Time for questions. So if you have a question, you can just walk up to the podium and you ask, and or come see me afterwards. But time for questions. Yeah. Well, no, but what I was doing was in the browser, you grab the window location origin, so that's at runtime. So you're not hard coding it. Yeah, basically just figure out whatever it is now and then pass it up. Yeah. Yes. It's per user. It's per user. Yeah. Yeah. So whoever needs to run the build task could get this and use it. Yeah. Yep. Anything else? Yes. Yeah, I only showed static resources. Yeah, that's another area for improvement. Yes, it shouldn't be too hard now that I got the static resources up, but I wanted to focus on that one because that's where a lot of the build process things often take place. But I'd like to be able to do that as well. Yes. Yes. Yeah, I'd love to add a GitHub push-pull commands like that. I didn't get that done yet. That's why it's open source. Other people, that's my goal. So other people can contribute those. Because a lot of the benefits of this is it's meant to be, a lot of the modules were kind of ports of Grunt code, and so it was really not that bad. Some of them I wrote myself, but you take a Grunt module and move it over really quick. That's the goal. So there's already Grunt modules for all that, so it shouldn't be too bad. Thanks. Why do I need Squid for this? That was for the user interface. I guess technically you could build something. It's really hard to manage. Just to be able to really quickly, click new process, show the whole process, and edit the steps, edit the actions, and all the fields on that, and have it, different fields and objects show up for different action types. It would have been insane to do that in Visualforce. I could do that. I did the UI in less than a few hours. That would have taken forever with Visualforce. So yeah, it's possible I could make compile the thing out into like a runnable version. That's an option. I thought about that, but right now it's just I want to be able to make it be with Squid. It's also extensible, so I could have specific areas that the user could define. Like I want to show this. I want to have these objects show, these fields show for this action type. That's a big part of it. Is putting any kind of configurable UI on top of this. That's what I'm doing for. I want to have Squid in there, so that's a framework that would let me do that. All right, I think we at time. I think we're at time. Okay.